Okay, so our next topic is related to how to measure the density in a lab, right? Let's suppose if we want to measure a density in our normal life, right? So how we are going to measure the density? So that is our next topic, and that is very much important related to the question because today we are not going to discuss the question, but in tomorrow's class we will discuss questions because we have enough topic or we have enough content to discuss the question. So next topic is related to measuring density. So let's suppose if you are having, let's suppose if we consider a stone, if we consider a marble or any irregular object, right, in our daily life, and if we want to measure the density of that material or of that object, so that is our main concern, that how we are going to measure the density of that object. So first of all, we need to know about the apparatus or the equipments, right? So which equipments we are going to use in our experiments. So these are your equipments or your apparatus. First of all, we need to have any type of object, regular or irregular. I'm not writing regular or irregular. So I'm just writing any object because we need to measure the density. So first of all, we need to have an object to which we are going to measure the density. Second, we need a liquid. Normally, it will be water. And why we are using liquid, that will uh, give you the idea when we discuss about the whole setup. Second one, we need to have a ruler. And next we have a digital balance. And measuring cylinder. So these are the apparatus which we are need going to use in our experiment. And now let's consider how we are going to perform our experiment. So our first step is, first of all, we consider a measuring cylinder, right? So this is our measuring cylinder, right? And what we are going to do with this measuring cylinder? In school or in laboratory, you observe a vertical cylinder type object. That apparatus known as measuring cylinder. I will also show you a real picture of the measuring cylinder. But first, let's we discuss about the concept. So there are marking on the measuring cylinder like this. And the SI unit, or we can say that the quantity which we are going to measure from this measuring cylinder is known as the volume. So the SI unit normally written on this cylinder is centimeter cube. So first of all, we need to fill it with water. So initially, let's suppose water is filled at this level. So this is the level of water. Okay. Our next step is, because we need to know about the density of the unknown object which we are using in our experiment. And first of all, we read the reading. So our first step is that record the reading. of the liquid in a cylinder. So this is our first step. First of all, we fill it with some height and then we note the initial reading. So this is our initial reading, right? And let's suppose this reading is 10 centimeter cube. This is just for example. And after that, we again put some object in it, which we are using to find out the density. Okay, so now we need to place an object in it. And we are using that same measuring cylinder with the water, which is placed initially. And after placing an object, let's suppose there is irregular type stone, which is placed in a cylinder like this, and the water level increases at this height. So now you observe that the water level will automatically increase when we pour or when we immerse a stone in it, right? Any confusion till now? So if you compare it with the initial stage, so you clearly saw that there is a difference in the height. This is the initial and this is the final. So basically there is a difference in the water level, right? So again we record the reading from this point, and let's suppose we are getting reading 35 centimeter cube. So initially we have 10 centimeter cube of water level, we can say that, and after immersing a stone in the water, we are getting value 35 centimeter cube, that is with water and with stone, right? So what is the actual volume, or what we can say that what is the increase in volume after immersing the stone in it? And what is 10 centimeter cube represents and what actually 35 centimeter cube represents? Any idea?
Mm,
Okay. So first of all, when we only pour water in the cylinder, so that is the volume of the cylinder, right? Because this centimeter cube represents you the SI unit or the quantity of volume, right? So centimeter cube represents you the volume. So when we pour some liquid in the cylinder, so 10 centimeter cube gives you the concept of the volume of liquid, right? Any confusion? So
no, sir.
this 10 centimeter cube is the volume of liquid, only liquid. And after that, we immerse stone into the cylinder, and again we are getting new reading, and that new reading is 35 centimeter cube. These values are not fixed. We are only taking for example to actually identify that how we can find the actual value. So this 35 centimeter cube gives you the value of what? Volume of liquid, because liquid is in the cylinder, and ऑब्जेक्ट राइट. बिकॉज पहले सिर्फ लिक्विड था हमारे पास, तो पहले लिक्विड का वॉल्यूम आया, फिर जब हमने उसमें स्टोन को रखा तो हमारे पास लिक्विड प्लस स्टोन का वॉल्यूम आ गया, राइट. एनी कंफ्यूजन?
No, sir.
ओके. नाउ इफ यू नीड टू फाइंड आउट द वॉल्यूम ऑफ अ स्टोन ओनली, अगर सिर्फ स्टोन का वॉल्यूम चाहिए हो तो हम क्या करेंगे? एनी आइडिया?
Mm. Then we will only give a stone
ओके.
and some water.
we need to do a simple calculation. What we need to do? We know that 10 centimeter cube is the volume of water, right? And after that, if we subtract it from 35, because 35 is the volume of stone and water. So if we subtract 10 centimeter cube from 35, so we know that we will get the volume of stone only, right? आई एम रिपीटिंग अगेन, देखो हमने सिंपल प्रोसीजर फॉलो करना है। 10 सेंटीमीटर क्यूब वॉल्यूम था सिर्फ लिक्विड का, 35 सेंटीमीटर क्यूब आपके पास वॉल्यूम था स्टोन प्लस लिक्विड का। तो अगर हम 35 में से 10 माइनस करते हैं, सो इट मींस वी आर सब्ट्रैक्टिंग द वॉल्यूम ऑफ लिक्विड। So 10 centimeter cube is the volume of liquid, and after subtracting from 35, we are only getting the volume of what? Volume of object, which is immersed in the cylinder, right? So we need to subtract the initial volume from the final one, right? And when we are going to subtract these values, what we will get? Let's suppose if we subtract, so this is our calculation part. So calculation means 35 centimeter cube minus 10 centimeter cube. 35 is the volume of liquid and object, right? Which is mentioned here. And 10 is only the volume of liquid. So if we subtract 10 from 35, so it means liquid got cancelled, right? Only the volume of object remains there. So this 25 centimeter cube represents you what? This is the वॉल्यूम ऑफ एन ऑब्जेक्ट। तो अब जो आपको वॉल्यूम मिल रहा है ना सब्ट्रैक्ट करने पे, वो सिर्फ ऑब्जेक्ट का है। एनी कंफ्यूजन?
No, sir.
Okay. And we need, basically our main focus is on density, that we need to find out the density. And what is the formula for density? Mass upon volume, right? So that is the formula, mass upon volume. So we calculated the volume from the experiment, right? 25 centimeter cube. Let's suppose for the reading we are having a volume of that object, right? This is the volume of an object. And we need to find out the mass. uh, Basically 25 सेंटीमीटर क्यूब इज द वॉल्यूम ऑफ स्टोन। देखो जो मेजरिंग सिलेंडर है ना, मेजरिंग सिलेंडर में तो आपके पास नंबर्स होते हैं, उसमें आप जितनी मेजरमेंट चाहो आप कर सकते हो, ठीक है। हमने वाटर फिल किया, वाटर को हमने 10 सेंटीमीटर क्यूब तक फिल किया, हमने इसको रिकॉर्ड कर लिया कि अभी हमने सिलेंडर में 10 सेंटीमीटर क्यूब जो है वो वाटर लिक्विड फिल किया है। जिस तरह कोल्ड ड्रिंक्स होती हैं 250 ml, 500 ml, तो वो उनका वॉल्यूम होता है। फिर जब हम उसमें कोई एडिशनल चीज रखते हैं, कोई भी एडिशनल चीज इमर्स करेंगे, तो वाटर का लेवल बढ़ जाता है। जिस तरह वाटर टब में भी होता है कि वाटर टब में आप कुछ अपना हाथ भी अंदर डिप करो, तो वो पानी उस टब से बाहर आना शुरू हो जाता है, राइट? क्योंकि वॉल्यूम इंक्रीज होता है। तो जब वॉल्यूम इंक्रीज हुआ, तो वॉल्यूम इंक्रीज किस वजह से हुआ? क्योंकि आपने एक ऑब्जेक्ट उसमें ऐड कर दिया। अब हर मैटर का कोई ना कोई मास होता है, वो जगह आपके पास स्पेस ऑक्यूपाई करता है, उसका कोई ना कोई वॉल्यूम होता है। तो इसकी वजह से आपके पास वॉल्यूम इंक्रीज हो गया। तो जो 10 सेंटीमीटर क्यूब था वो प्योरली लिक्विड का वॉल्यूम था, और 35 सेंटीमीटर क्यूब मिक्स वॉल्यूम है स्टोन और वाटर का। तो अगर आप वाटर या लिक्विड का वॉल्यूम माइनस कर दो जो कि 10 था, तो बाकी जो वॉल्यूम बचेगा वो किसका होगा?
Rock.
ठीक है, सिर्फ रॉक या स्टोन या उस ऑब्जेक्ट का जो हमने सिलेंडर में इमर्स किया, ठीक है। अब कोई कंफ्यूजन?
No, sir.
ओके, मतलब ये इस तरह से हुआ कि हमारा बिल बना लेट सपोज 35, उसमें से आपने दिए 10। अब जो बाकी 25 बचे वो किसने कंट्रीब्यूट करने, वो मुझे कंट्रीब्यूट करने। ठीक है। तो इसी तरह से यहाँ पर वो जो 25 था वो पार्ट था स्टोन का या उस ऑब्जेक्ट का जो इमर्स किया। तो इससे हमें क्या हुआ, हमें वॉल्यूम मिल गया। तो हमारा जो डिफिकल्ट टास्क था वॉल्यूम फाइंड आउट करना, वो कंप्लीट हो गया। एंड इफ वी नीड टू फाइंड आउट द मास, सो व्हाट इज द प्रोसीजर टू फाइंड आउट द मास? apparatus में देखो, is there any apparatus which help you to find out the mass? We already discussed in our last class that how to measure the mass.
Mm, by by screen balance. My
Yes, by digital balance, because we know that in or in grocery store or on shops you saw that there is a digital balance, or we can say that digital meter, we can say, when we place an object over digital balance, so that will give you a value in grams or in kg, right? So basically that is digital balance. So we can easily find out the value of mass using digital balance. And when we find out both quantities, that is mass and volume, our final step is to substitute in the formula, right? So this is our final step. We need to substitute the values in this formula and we can easily find out the density, right? So this is the method to find out the density. Okay. Any confusion?
no, sir.
So this is very much important because tomorrow when we talk about the questions, so you observe that many questions are related to this concept, which is related to measure density.